All right, let's peel back the curtain on the invisible tech that powers pretty much everything we use today, high-density interconnect PCBs. They're the real unsung heroes tucked away inside our gadgets, and we're about to figure out how they pull it all off. Let's dive right in. Really think about it. We want more power, more features, faster speeds, but we also want everything to be smaller, lighter, and sleeker. How is that even possible? Well, for the engineers designing this stuff, it creates this huge, fascinating paradox. And that's our first big topic, the massive challenges that come with making technology microscopic. It's not just a matter of shrinking things down, it's a constant knockdown, drag-out fight against the laws of physics. And what's so wild is how this all creates a kind of vicious cycle. See, for faster performance, you've got to shorten the path the signal travels. Simple enough. But when you cram all those components closer together, they generate a ton of heat. So to deal with the heat, you lower the voltage. But then, oops, that makes the whole circuit super sensitive to electronic noise, all while the computer chips themselves are getting smaller and need these incredibly dense connections. It's a puzzle that old-school circuit boards just can't solve. So what was the fix? We needed a major breakthrough. And that's when the high-density interconnect printed circuit board, or, HDI PCB for short, stepped onto the scene. This is the elegant solution that completely shatters that paradox of miniaturization. The key word here, the real magic word, is density. An HDI board isn't just a regular board that's been put in the dryer and shrunk. Nope. It's a total redesign from the ground up that lets engineers pack way more connections into the exact same amount of space. It's all about being way, way smarter with the layout. And this right here makes the difference crystal clear. On a traditional board, you've got these clunky connections called through-hole vias that literally punch all the way through the board. Think about it. They waste precious space on every single layer. But HDI boards, they use these microscopic connections called microvias and much, much finer lines. This gives you this incredible jump in density and often lets designers use way fewer layers to get the same job done, which, trust me, is a huge deal. And that's really the big takeaway. This isn't just a small step forward. The efficiency of an HDI design is so massive that it can do the job of several older boards, all on one single compact unit. This is the secret sauce that makes the sleek designs of modern tech possible. Now, of course, not all HDI boards are created equal. They're actually classified by how complex they are. You've got your simpler Type 1 boards with just a single layer of microvias, but then you get into the more advanced stuff like Type 2 and Type 3 boards, which start adding buried connections between inner layers, even multiple layers of microvias. That's how you get those incredibly intricate designs. Okay, so we've got it. HDI boards are smaller and way denser, but the advantages go so far beyond just saving space. Let's dig into why smaller is actually smarter, faster, and, get this, often cheaper. First up, getting products out the door faster. Because the layout is so much more efficient and placing components is easier, the whole design process speeds up. And since the electrical performance is better, thanks to things like microvias, you have fewer errors. Fewer errors means fewer redesigns, and that means products get from the drawing board to the factory floor in record time. Second, they're more reliable. Believe it or not, those tiny microvias are actually way more robust than the old through-hole kind. Because they're smaller and used with thinner materials, they're much better at handling thermal stress, things getting hot and cold. This makes the final product a lot less likely to fail down the road. And third, and this is the one that might surprise you, is lower cost. You'd think, oh, this is super advanced tech, it must be more expensive, right? But by designing smarter, you can radically reduce the number of layers you need for a circuit board. And fewer layers means less material and a simpler manufacturing process, which can lead to some really significant cost savings. And here's a perfect real-world example. In one project, engineers took a bulky 14-layer traditional board and replaced it with a sleek 8-layer HDI design. Not only did they slash the layer count almost in half, they also cut the total area of the board by 40%. That is a massive win-win for both cost and size. So how on earth are these incredible boards actually made? We're talking about building things with features smaller than a human hair. This takes some seriously advanced, almost futuristic manufacturing techniques. It really comes down to 3 key stages. First, something called sequential lamination. Basically, the board is built up, one super thin layer at a time, to make sure everything is microscopically precise. Next, high-powered lasers come in and drill the teeny tiny holes for the microvias. And finally, they use a clever technique called via in-pad plating, which puts connections directly under the components to save every last millimeter of space. And just to give you a sense of scale here, the industry standard says a microvia has to have a diameter of less than 150 micrometers. That's thinner than a human hair. We're talking about manufacturing on a truly microscopic level, where even the tiniest little mistake can cause the whole thing to fail. It's just incredible. So let's bring this all back home. This isn't some far-off sci-fi tech we're talking about. It is the engine running the world all around us, and I can almost guarantee you it's in your pocket right now. HDI technology is absolutely essential pretty much everywhere. I mean, of course, it's in our smartphones and laptops, but it's also in the dozens of computer systems in a modern car, it's in life-saving medical devices like pacemakers and insulin pumps, and it's in the gigantic infrastructure that powers our global communication networks. HDI is truly absolutely everywhere. The push for smaller, faster, more powerful electronics, it's relentless, it's not slowing down, and high-density interconnect technology is the engine making it all happen. It's enabling things today that were just science fiction a few years ago. So as this tech gets even denser, even more capable, the only real question is, where is this microscopic hero going to take us next?